Hi all, and welcome to the Accelerated Data Lakes webinar. My name is Sharon and I'll be helping host today's webinar. We'll be running an hour-long session, which will include 15 minutes of Q&A at the very end of the session. We're joined today by Paul Macy, who is our Big Data Specialist Solutions Architect at AWS. Lengthy title, I know, but Paul will be our presenter for today. Take it away, Paul.
Thanks, Sharon. Well, good morning, everyone. As Sharon said, my name is Paul Macy. I'm a solution architect at AWS, specializing in big data and analytics. And so thank you for taking the time to join me today as I present the Accelerated Data Lake webinar. Just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the question box in your GoToWebinar control panel, and I'll answer as many as I can at the end of the webinar. And finally, the slides will be made available at the end of after the webinar. Today will be a deep dive into a data lake solution. However, to begin with, I'd like to take a few minutes to cover what challenges organizations face to really leverage and gain insights from their data. Then I'd like to talk about how the accelerated data lake solution can provide a way forward to address these challenges. And then we'll dive right in and I'll go through the architecture, how we onboard data into the environment. I'll walk you through a live demonstration of the solution. I'll do a brief wrap up and then I'll take some questions. So let's get started. One of the biggest challenges we see organizations face with are data silos, where data is spread across multiple systems, multiple environments, in spreadsheets, SharePoint lists, or even Word documents on someone's laptop. And trying to bring all that data together can be a near impossible task for many organizations. However, they know that if they could bring all of this data together, it would be able to produce insights and benefits to the organization that they could have never got before from their current environment. The second challenge we see is with security, where data is stored in a range of locations where some of those areas have no security controls in place. The data has not been classified, and worst of all, the data could be joined and some information inferred from it. Then there's a potential for a data breach. We hear from organizations that they have poor or no data governance when it comes to understanding their data. They want to know where their data came from, what's in it, how and when it was created, have business, operational and technical terms, and want to be able to search for any of this information. And finally, we hear about scalability, where the volume of data being collected and stored and then queried is accelerating at a rate that the servers and systems are struggling to keep up. So to address those challenges, I came up with a solution known as the Accelerated Data Lake. So firstly, the solution is centralized and scalable using Amazon S3 as the data store. So you will at last be able to bring in and join data from your data warehouses, spreadsheets, APIs, or even things like SFTP servers. The moment the data arrives in the data lake, it is secured using rules that can include data classification and use cases. After being secured, metadata is then applied. This initially can include things like data lineage, timestamps, checksums, data owners, application owners, together with business and technical terms. And all of these can be easily customized. Users are able to use the SQL skills they already have to query the data, and it can be accessed by many of the modern BI visualization tools. The onboarding and processing of data files is a repeatable pattern that can be easily extended and customized. And finally, the solution can become your organization's analytical, data science and machine learning foundation, where services such as Athena, our interactive SQL query service, EMR, our big data service, or SageMaker, our machine learning service, all have the ability to directly access this data. The accelerated data lake solution future-proofs your organization so that as you explore additional AWS web services or as new services become available, they will also be able to access the same data foundation. But you know what, best of all, the accelerated data lake is available to everyone today. It's on GitHub. We've open sourced it and it's at AWS Samples Accelerated Data Lake. It includes the data lake pipeline, which is a set of CloudFormation scripts, instructions on how to deploy the solution, and data configuration, security, and metadata templates to get you up and going fast. You can deploy the solution yourself, or you can engage our professional services team or one of our many AWS partners. So let's take a look at what success looks like with using the accelerated data lake solution. Firstly, we recommend starting small, choosing only a few data sets that can produce some insights that your organization can immediately gain benefits from. You can then leverage the accelerated data lake solution and the security and metadata templates included to establish a repeatable workflow. You then produce the insights for your organization, improve and iterate by adding further data sets and refining your security and metadata, and repeat. Let's now take a look at the architecture of the accelerated data lake solution, beginning with the high-level data flow. The solution is broken up into 4 stages. The first stage is the initiation stage, where a data file is processed either at a particular time or the moment it arrives in S3 using AWS Lambda, our serverless service. Then there is our processing stage, which is the repeatable process where the onboarding of data into the data lake actually occurs. We then have the cataloging stage, where the S3 object's metadata is stored in DynamoDB and indexed with Elasticsearch. Using Elasticsearch allows us to perform ad hoc querying of the metadata using API calls, or the metadata can actually be visualized using Cabana dashboards, which are also part of the Elasticsearch service. And finally, there is the data lake storage stage, where all of the processing for the data file is, when it's all complete, the file is moved from the staging location for when it arrives in S3 and moved to a raw location, making it available to the organization. As I mentioned a few slides back, the data lake solution is able to be accessed by most of AWS's services, enabling analytics and insights. Let's now dive a little deeper into the processing pipeline stage. So using the example of a data file immediately being processed once it arrives in Amazon S3 in a staging location, a Lambda function is triggered from the file being saved in S3. Then the Lambda function, which contains a payload of information both about the data file and the event that happened itself, starts an AWS step function. A step function lets you design and run serverless workflows. In this case, the step function performs a series of steps, each of which are separate Lambda functions. The first Lambda function finds the matching file specification for the data file in S3. A file specification is like a list of properties or settings for each data file type. It is stored in the DynamoDB table, and it includes each data file's S3 source and destination location, its metadata and security settings. So there's one file specification for each data file type. So using the file specification information that we get from the DynamoDB table, validation is performed on the data file. S3 object tags are added to the S3 data file. Now, S3 object tags are key value pairs, and we use them for security, and we create values like classification is sensitive or PII is true, and they are used to control access to S3 objects in conjunction with using Amazon Identity Access Management. Metadata is then added to the S3 object using those metadata tags. Then the object's metadata and security values are stored in and cataloged in DynamoDB and Elasticsearch. And then finally, the S3 object is moved from the staging, or where it was landed, to a raw location. And at that point, the data can be accessed by the organization based on the security that was applied. So let's take a look at how we onboard a new data file type into the data lake. Onboarding of data is made up of two steps. First, you create one of those new file specification entries in a DynamoDB table, which I've called data sources. And remember, this file specification contains the file settings of the new data type, S3 object tags, and metadata. The second thing we have to do is actually create a folder structure in S3 for where the new data files will be stored in both the staging and raw bucket locations. This is an important step as it not only keeps your data organized, but makes querying of the data using services like Amazon Athena much more optimized and efficient. So let's now look at each component of a single file specification that is stored inside DynamoDB. And then what we'll look at afterwards is how we can structure our S3 buckets and folders for optimized storage and querying. First off, we have file settings. Now, hopefully you can all see this, but as you can see, because we're using DynamoDB, it's a NoSQL database, the information is stored in JSON and can be easily customized. To begin with, as part of the file settings, we need to create a unique name for the file type. In this case, it's sample CMX. We also then include a file name pattern using a regular expression, and this is used to match the data file to its correct file specification within Dynamo. And then we add the staging and raw locations for the new data type. And that's all we really need to do to begin with. Next are the object tags, those security tags I mentioned earlier, which are used for applying security to the S3 object. As you can see, we've included some examples like data classification, data owner. However, you can create up to 10 of your own key value pairs to use as S3 object tags. Then within the file specification, we have two types of metadata. The first is simple metadata, which could be a data owner, timestamp, MD5 checksum, or a description of the data. And these values are attached to the S3 object or the data file within the staging location. And then we have extended metadata, which is cataloged to a separate DynamoDB table, as well as in Elasticsearch. And as you can see, it's quite comprehensive. These extended metadata values can include business, operational, and technical terms, field names, data types, and field aliases. And again, you can customize all these values. Let's now look at how we can structure our S3 buckets and folders for optimized storage and querying. By default, when the accelerated data lake solution is deployed, it creates a group of S3 buckets, and they're staging, raw, curated, gold, validation, data discovery, and logging. And yes, all of these names can be customized. Each of these S3 buckets, they represent different states or aggregations and views of the data that begins its life from, in most cases, disparate systems and sources. So let's take a look at folder structures within the S3 data lake. Within the staging bucket, we find that storing data in folders that represent a hierarchy of the source system or schema, and then by table or file type, have been really effective ways of organizing the data as it arrives. For the raw bucket, which usually stores untransformed data from the staging bucket, but actually has the security and metadata applied to the objects, storing the data in a data domain or like a topic rather than a system or source really brings to life the purpose of a data lake, which is, you know, to bring all of this data together regardless of source in an organized fashion and making it really easily consumable. So if you look at the example here, I've grouped wireless related data into a wireless folder. So CMX data, maybe you can see here another folder, that might be provided by a network team on a daily basis, while the API raw data file might be an hourly file coming in from an external API call. But as you can see, they're rolled up underneath a single location called wireless. Now, by doing so, there is another benefit to storing data by data domain. By using Amazon Athena or Amazon EMR, our big data service, you can now query the data in S3 like a database. So where the wireless folder is like a schema, the CMX and API raw folders are like tables, and the folders below them are like data partitions. So you can potentially do queries like this. Using SQL, the number of users using CMX can be select the count of the user IDs from the CMX folder where the year is 2019. Or we can actually join folders by doing queries like this, where we're saying, let's find who the common users are between CMX data and an API feed for the same year. And all of this can be done without a database and at scale. Now, on a side note, before I go on across to the demonstration, I've spoken a lot about S3 object tags and metadata, and so I'd just like to quickly clarify how they are applied to an S3 object. So just recently I was in New Zealand, so I've got this photo here. I thought it was a pretty good photo. And you can see when you take a photo with a camera, it actually creates EXIF data or metadata about the image. And you can see that the data isn't actually attached to the image, but is effectively attached to the file. This is conceptually the same when we're working with S3 object tags and metadata. They aren't added to the data, but they live next to the data. So the S3 object, whether it's a CSV file or Avro or Parquet or whatever the format is, that remains unchanged. All right, let's get on to this demo. So the demo today I'm going to show you is showing you real data being processed live using the accelerated data lake solution. The data is being generated from an AWS IoT simulator that produces vehicle data. Now, the IoT simulator is available for anyone to deploy themselves, and I've put the link up there and you'll get this as part of the pack. And so you can give that a try if you like. The simulator lets you create your own devices and integrate them with our AWS IoT services. If you would like to know more about our IoT services, let me know after the session and I'll connect you with Craig Lawton, who is our specialist solution architect focusing on IoT. So in the demonstration, I will be using the AWS console, you know, the web console, and I will be showing you the S3 data lake structure, how the S3 objects are actually having security and metadata applied. I'm going to show you the step function that is processing each of the files through the pipeline. We'll take a look at the Dynamo DB table, and it's called data sources, like I mentioned before, that lets you onboard your data in literally minutes, not hours or days. And you'll see why in a little while. And then I'm going to show you the Cabana dashboard that is displaying live metrics of the data arriving in the data lake. So let's jump across to the AWS console. Just jumping across. Okay, so here you can see I have the IoT device simulator web page open. Now this is not the web page for where you go and get the code for the simulator. This is actually the web page of the simulator running, and you can see that I have had in the past 99 vehicles in this particular case running. And if I go across to automotive here on the left-hand side, just wait for it to come up. What you'll see is I've still got some vehicles running, and you'll see over time I've had lots of different VIN numbers of vehicles running over the last month or so. Now that data is being streamed into S3, and what I'm going to do is take you across to the S3 page from the AWS console. Now, as you can see, the solution has pre-built all of the buckets that I spoke about earlier, where we have staging, we have raw, we have curated, we have gold, we have validation, we have data discovery. And again, as I mentioned, these are all customizable. Now, the data is arriving from the IoT service into staging. The trouble is it's happening so quickly that if we try and look at that data, it's already gone. So this data here is actually from February, and you can see that the way that I've organized this structure as I'm clicking through. So you can see I'm in the staging folder bucket, and as I go through, you can see the partitioning and organization of the data. But you can see I've got no March data coming through, and that's because it's being immediately processed. So I'm going to go back out to the top level of S3, and I'm going to go to the raw bucket. Now, as you can see, I've actually got a different folder structure than what I presented earlier, but you can see it's grouped by a domain. So if I go into vehicle, which is my domain, I can see there's other sets of data that support that domain. So I could do queries that actually relate to weather on vehicles and traffic all at once. In this particular case, I'm going to dive further into the IoT data. So when I go into IoT data, you'll see that as I click on each folder, just like a normal file system, I'm moving through effectively data partitions. Now, they are by date, but they can be whatever structure the data needs to be to support the initial organization of the data. Now you can see here, I've got the 12th, the 3rd, and the actual simulator is a little bit slow because it is producing data today, but it's just a little bit out of time, but it is running. Now, these are the files coming through from the simulator, and what I'm going to do is click on one of these files, and I'm going to show you the properties of the file. Now, when I do that, I've got a range of different settings here, and one of the settings that we spoke about earlier were tags. And this is where we manage how we can provide access to the S3 objects. Now, if I click on this little link here, you'll see that automatically, as this process is running, it's creating 4 sets of tags. And you can see here, I've got one that says use cases analytics, classification is private, and I know who the application owner is. Now I can create a rule that says, hey, you know what? As long as a person has the access to a use case that's analytics and the classification is private, they can access any of this data. And that's done through IAM using the words that are against a S3 object. So it's pretty powerful. You're able to create context and apply data classification and user access all in one area. So that's for the object tags. Let's take a look at the metadata that's applied. Over here, you can see there's quite a lot of metadata. You can see that we have who's the data owner. We've got the analytics team. What is the quality of the data? What's the description of the data? I'll go down the bottom here. Where did it start? Where did it end up going? What's the file size? There's the checksum, so I know that if anything changes within this file, and in this data has been cataloged inside the data catalog in both DynamoDB and Elasticsearch, I know that this checksum shouldn't calculate to be the same. So you can see we can actually put a lot of different fields in here, and you can add as many or as little as you want, and they can grow as your organization matures with their metadata requirements. So let's take a look at the step function that is actually processing all of these files. A step function, again, provides a flow that allows us to use a range of different services within AWS to go through either a series or parallel process. In this particular case, we have one called the file processor. Now I'm going to click on that, and you'll see as I go in there, I love seeing, this is what I love, you know, succeed, succeed, succeed. And you can see the time here is actually right because the data lake solution is tagging, is running correctly in the local time. Let's go in and take a look at the actual step function and what actually occurred in there. Now, as I scroll down, I'm just going to expand on this screen here. And you can see this step function, as I mentioned, goes through a range of steps. And some of these weren't in the previous slide, only for simplification. But you can see here, we're finding a matching specification. We're attaching metadata. We're attaching the security tags. We're sending the tags and metadata to Dynamo. We're cataloging the tags and metadata in Elasticsearch. And then we're moving the file from staging to final, or it could be from source to destination. You can make any of these names up as you wish, but our standard solution has these names. And what you can see is that the path is very, very simple, and you could add new features in as you need to without having to recompile the whole solution. Now, what I mean by that is you could create a new Lambda function that might need some additional validation, or you wanted to split the data at a particular point. Or you could write a Lambda function, which is written in languages like Python or JavaScript or Java or PHP, and you can write it so that it will split that data out at a particular step here without having to recompile the entire stack here, because they're all individual Lambda functions. And you can see here that if there's any problems at any stage, we add the error to a queue, and we actually send off a notification to a particular, whether it's a team or it goes to an email or it could go to a mobile. We have this ability to really choose the direction of the workflow very easily. So that's the step function. Let's take a look at the Dynamo table that looks after the file specification. Now, that was where we had those 4 blocks of settings for each data type that you bring into the environment. So let's go in there. You can see here I'm in DynamoDB, our NoSQL database, and we have a table called data sources. Now, the data sources table has a unique key, which is the file type. So when I click on that, just keep that in mind. When I click on that, I'm going to go across to items and look at the items within the actual table. And you'll see here the file type. I've created one for connected car. I've got one for CMX. I've got another one here. But let's go into the connected car one and just take a look at what's going on inside this settings file. Now, it is quite a lot of data, so I might break this up into stages. But the first thing is we need to give each of the entries of each data type a unique name. In this particular case, you've got connected car. You may have SAP HANA CRM data. You may have an Ateza schema. You may have something else. The great thing is you can make these whatever you need to be for your organization. And you can see there's no coding here. All we're doing is putting in words to onboard data. Let's take a look at the file settings, which is the main part of how we configure the movement and consumption of the data from staging to raw. What you can see here is that we have the file name pattern, which is the regular expression that the file name needs to meet to actually be processed. We have a staging folder and the bucket, so those combined actually define where the source of the data is coming from. And then we actually have the destination, which is the raw bucket. And again, you can make these really go anywhere. We can change the names of these to suit your organization. But for the solution, we have used staging and raw to get you going. We can even choose whether to calculate the MD5 checksum for each file as it's being processed. If the file processing succeeds, we're able to send a notification to a team saying, yes, it succeeded, or we could send that off to another task. If it fails, we could send that off to another notification endpoint, and something else can happen in reaction to a failed processing step. So let's take a look now at the metadata. Actually, we'll do the security tags. And you can see here, I've got security tags that say application owner is IoT team, classification is private. Well, do you know what? I actually might need to change this. And if you've got a data governance team or a chief data office, they might have authorization to do this. And they could go in and say, well, you know what? From now on, this data is now going to be sensitive. And you know what? I've just changed it. And so by simply making small changes to the settings in the DynamoDB entry, that now will change the files as they are coming in through the pipeline. Now, this can trigger a retrospective update across all of the previous files as well. So the power of this is amazing. You don't have to code. You can change the words using normal typing in an environment that has a GUI, and that will propagate out through the rest of the environment. Let's take a look at metadata. As you can see, we have got these fields as a starting point. I may decide, you know what, this isn't just a vehicle, it's now going to be trucks. We know that if I could spell correctly, it'd be trucks. And that now will also change the rest of the environment. And we know this is now platinum because we know the IoT service is running really well. And I think that will do. The minute we make those changes, that's being propagated through the environment. And finally, we have extended metadata. Now, this can be anything that you want. I've included things like what is the format of the data within the actual data set. I've got still the data quality. I can include data elements where each of the fields I can include an alternative name, a description, and a timestamp. Now, some people might go, you know what, we can use Calibra, we can use Informatica, we can do all of these things with these services by other providers. The one thing we do find with going down the DynamoDB and Elasticsearch approach is that a lot of organizations don't know what they want to include as metadata before they make a large commitment to buying a software application which is going to help them with their metadata. So we find that if we have customers come in and actually start using this environment and slowly maturing their metadata, a year later, we see them looking at it going, you know what, we're ready to have this conversation with those other vendors and actually look at bringing that into a different solution. But what a great way to start, that you can go through, customize, update, and mature all of your security and data governance with just a change of a few words inside a table. Finally, I'm going to show you the data coming through into Cabana. So Cabana is part of the Elasticsearch stack, where we have Elasticsearch as the indexing engine. Cabana is the visualization engine, so you can create dashboards and do interactive querying on the data. And this is live, so what's happening is, as data is coming in through the simulator, I'm able to create effectively like a SOC for data integrity. I've got the files coming in. I'm looking at the files coming in just generally as counts. I'm looking at them over time in weeks and in blocks. And then I'm looking at, again, another view broken up again by aggregate files. And this can be customized so that you can have a heat map, you can have geospatial data, you can include a whole range of values to really augment the metadata, and that can be displayed inside Cabana. So there you have it. We're able to go through, store data in S3 by configuring a Dynamo entry inside a table. The step function continually runs through the same pipeline of work. So when you onboard data, the only thing you need to do is really add a new entry inside Dynamo and add some new folders. And you can begin visualizing your data and querying your metadata within Cabana and Elasticsearch. So let's jump back to the presentation and we'll close off. Always easier said than done. Okay, give me a moment. Okay, made it. Okay, so to wrap up, the accelerated data solution really gives you the ability to centralize and scale your data. You can have security from day zero, so the moment it lands in the environment, you know that only the users or services who should be able to access that data can. You know where the data came from. You can have data lineage, data owners, application owners the minute the data arrives. You can query it using languages and tools that are common today. The solution is repeatable and extensible by using that pipeline and just onboarding more data sets. And it becomes your analytical and data science foundation. It's really going to enable your data, support your data security and data governance, grow and scale in harmony with your organization, and you can grant the environment access to your analytics, machine learning, and AI ecosystem within AWS. I've included a few links in the deck, which hopefully you get a chance to have a look at. I've included security because I believe security is one of the most important things to talk about with anything that we do in cloud today. I've again included the link to the GitHub repo for the accelerated data lake. I've got a couple of blogs out. The first one is about how we take those disparate systems and siloed data and how we start looking at that data in a different way, in looking at them as data domains. And then we have the second one where we're securing our data using those security object tags on S3 and also using metadata tags. I did see recently there was another blog put out by woot.com, which is a bit like Daily Deals, and they built a very similar kind of serverless data lake on AWS. So I recommend you take a look. So that's it. I might call it a wrap and take some time for some questions. Okay, so the first question I've got is, can data be validated and enriched in the data pipeline? So yes, the way we go about validating data in the pipeline is part of the actual accelerated data lake solution. What happens is, as one of the steps inside the step function, there is a validation step. In my build, I don't have it in there, but when you go to the GitHub repo, you will be able to see there is a validation stage. And that happens at the very beginning because we want to be able to say, well, okay, I'm going to go into Dynamo, I'm going to find the matching file specification, and then I go and find out what I need to do to validate the data. And as part of the solution, we use a framework. I'm just trying to remember what the framework's called now. Can't remember off the top of my head. Is JSON schema and CSV schema, and they're Python libraries that are available, and we use them as our validation method. So you can, with those particular frameworks or libraries, you're able to say what order a set of headings should be inside a particular data file. You're able to say, as well as that, what contents need to be in each of the fields. So you can say, does it need to be numeric? It needs to have, you know, A, B, or C in a particular field, and so on. And that exists for CSV and for JSON data. So I've got another question. Can web services be invoked to validate and enrich the data? Sure can. There's no reason why you can't trigger another task off to go to another service to actually do a particular pre-processing of data and actually augmenting of data. Generally though, we find that it's better to land the raw data into the raw location unchanged so that you do have this source of truth, and then trigger a second Lambda function to actually go and do the further augmentation of the data or enriching of the data. Can Athena query those metadata tags? I would say yes, we could do it. I think that it would be, we have a couple of ways of doing it. It's probably better, you'd end up duplicating it because Athena really does rely on having a data catalog or we use AWS Glue to actually create a catalog that lets you connect to DynamoDB. There's a method there, but that doesn't get you to Athena. So I'm just thinking this out as we go. I would think that the only way you could really do that with Athena at this stage would be to duplicate that data into S3 in a file. And it's not a lot of data, so that would be fairly straightforward to do. Okay, I have another question. Can you point me to where I can find out how to connect my organization's data sets to S3? Okay. Now, we can't point you to how you can connect your organization's data sets to S3 because there's probably lots of different permutations, but we do have a range of services to help connect data that is on premise to be sent to S3. We have, what can we start with? I suppose we can start with File Gateway. We can do a snowball. I'm not going to go through all of these definitions right now. There's a range of different things. I know hopefully you can Google these or go onto our site. We can use Data Sync. There's a new service called Data Sync. If you have databases on premise, we also have our data migration service that not only moves tables, it does have a schema conversion tool as well to help you map out your schemas on premise to go to our databases or even to S3 in AWS. Is pipeline part of data lake? Could someone who wrote that just give me a little bit more maybe on that? Are we talking about is the step function pipeline part of the data lake maybe? Does anyone want to just extend that a little bit? Because yeah, okay. Yeah, so the data lake itself, if you think of how, okay, so I'm going to answer it like this. The data lake in S3 is really the data foundation. The step function pipe is really the process or the pipeline for moving data from the various different buckets or even other services into the data lake. So it supports the data lake, but it's not really part of the data lake. The data lake really is just the S3 storage layer in this particular case. Of course, data lakes can be also databases and they can be a range of other services within AWS, but for this particular solution, the base layer is the S3 bucket, the S3 buckets. Okay, does anyone have some more questions? Okay, How do metadata settings make the data more secure? Okay, so metadata on its own doesn't make it more secure. All that's doing is providing you information about the actual data. What we use to make things more secure are the object tags. And the way the object tags work, I actually have a slide. If I could just flip through, I'll see if I can find it for you. I'll bring a slide up which actually might be able to answer that if I've got it here. Give me just a moment because it's maybe down a bit lower. Now this is in one of my blogs as well. And I'm just going to go and play it. I'm just going to show you this current slide here. So here we go. The object tags combined with storing the data files in a particular data domain structure allow you to create a combination that when used with IAM allows you only particular people or users access to sets of data. Oops, sorry about that. This is my Mac. Now, what you can see here, if we look at that wireless scenario that we looked at before, we have CMX data, and you can see that I've actually got it down as a sensitive classification, and I've got the Netgear one here, which is public for whatever reason. Now, what I'm able to do is create those S3 tags to represent each of the data classification types within a particular data layer, like as you can see with those folders. And then what happens is I can use those words within identity access management. Now, the way that would work is, let's say I create a policy, a set of rules that say, well, okay, if I want someone to be able to access CMX data, I create a policy within identity access management called wireless sensitive. Now, within that, I'm able to use the object tags as a set of rules for deciding whether someone or a service can access the data within a particular S3 location. And the way I would do that is here, I'm able to create a set of words in the actual policy that says the classification equals sensitive and the domain equals wireless. So that naturally, when attached to a user, a group, or a role, and then potentially integrated with a Active Directory, will automatically decide whether, based on your access, you can get access to CMX just using those words. So you can imagine if you have classification is sensitive and the domain is wireless and you needed to have both of those, and your S3 tag for a CMX folder only has one of those, well, you're not going to get access to that data. You need to have both of those terms. It can be an and or scenario, but we could probably deep dive into that separately. But I would definitely take a look at the second blog that I've put up, which covers how we do security using the data domains, the policies, and the S3 tags. Okay. Any more questions? I'm not scared. I'll try and answer anything. Nothing personal, but I can answer most things. One question that I get asked a lot is, what is the difference between Lake Formation, the new service from AWS that was announced at reInvent 2018, and this solution? It's a little bit tricky. They're not identical. Lake Formation is a higher order service which does build out identity access management policies. It does build out S3 bucket structures, and it does have an awesome feature of being able to do machine learning to work out data commonality across multiple data sets, which is just fantastic. The thing that separates that solution from what the accelerated data lake is that the accelerated data lake provides you with the templates and the quick start to actually really start joining data today. if you have some sample data sets that you want to put into S3, you've seen now that you've only got to put some couple of folders inside S3, copy some of those Dynamo entries that I've got. You can just do copy and paste and you create new ones and just onboard that data. That's where the difference is. You're able to use the templates and the customization of the CloudFormation script to really custom build a solution that's really fast to deploy and really quick to get insights. It's really about that customization and speed to delivery. Okay, so I have another question, which is, how do you allow search against Elasticsearch with security in mind? Okay, so in that regard, there's a range of different ways of doing that. Obviously, one of the most common ones we recommend is using Amazon Cognito, and you're able to create a set of user pools, and you're able to, those pools are granted access to particular services. So that's one particular method. So definitely take a look online at Amazon Cognito, because that is one method, and there's a couple of blogs about how we go about securing access to Cabana dashboards and Elasticsearch using that method. The other thing that you can do is when you're in Elasticsearch, you are able to create policies that are going to control quite granularly who can access the Elasticsearch environment, and that can be down to an IP address or an account or even a user. So lots of different ways of doing it. Definitely go into the Elasticsearch documents, and you can read about how we have different approaches to enforcing security with Elasticsearch. Do I have an example IAM policy for this page? See the blog post. Okay, give me a sec. I might. Okay, here we go. Who would have thought I'd have one handy? What I'll do, I'll try and, I've got to just put something down here. Let me see if I can, oh, sorry about that. If you've just gone all, I'm going to try and zoom in here and show you this guy. So here is an example. I'm going to try and, you know what I'm doing? I'm trying to go up on the board and talk, but you can't see me. Let me just point with a mouse. Got to get back here. Sorry, it's just a little bit tricky trying to zoom in and do all this. Let me just jump back out. Now I've destroyed this now. Hang on a second. Sorry, everyone. I was trying to flip multiple screens to get to this slide. Okay. Yeah. Actually, I did have, so what I might do is, if you want to, you could email me that, and what I'll do is I'll send out that information as part of this. Actually, that's what I'll do. I'll add how we do an IAM policy and all those extra parts to the slide deck, so you've got that extra information. This is a good one. I've got one more question here, which is, would Redshift fit into this process as in from S3 staging to Redshift? I see this as, there's two parts to this. When we're moving from staging, I really love seeing that we keep the raw data in a raw state inside S3. And there's a couple of reasons for it. The first thing is, and I'm not saying you don't go to Redshift, I'm not saying that, but I definitely believe that if you save the data in raw, in the raw bucket, or even when you start optimizing the data by compressing it and then indexing it and a whole range of other things, what that allows you to do is provide a real granular level of data for the art of the possible, that someone could come in there and really try and join data that they can never join before. I think that's a really important thing. So it's agnostic to the service. So if you did want to use SageMaker, or you wanted to use some of our our machine learning or AI services, you could do it. But then there is a time, and we do actually have code for this as well. I need to put this on GitHub, is an automated process of when the data arrives in the raw location, it triggers a secondary Lambda function, and that Lambda function then moves the data from the raw location directly into Redshift, into a particular table. And you won't believe it, the code that is written to do that is almost identical to the data lake pipeline, because the Lambda functions are really light touch and they're very granular in what they do, but they're also quite agnostic. So the process of stepping through and moving data from from the raw bucket or any bucket to Redshift is go and get the configuration from Dynamo for which Redshift, for which data file. Go and get the Redshift command, which will be copy from S3 to Redshift. And then we've got some parameters for copying from S3 to Redshift, which includes what is the source format, what is the delimiter, what are the fields, and so on. So yeah, we definitely see that Redshift is an endpoint, but also as data is getting larger and larger and larger, we're seeing people storing data in Redshift that's only potentially 60 days old, maybe 3 months old, and they keep the rest of the data still in S3. And the reason being is that you're able to bring up the older data, the warm data, or even the cold data up from S3 using Redshift Spectrum. And you're only paying for the data you query. So even though Redshift Spectrum spins up a set of compute to actually do the movement of data from the S3 location up to Redshift, you're only paying for the compute of the querying of the data coming up through to Redshift, only for that data that needs to come up to Redshift to support the query. I hope that answers your question. Okay, this is a good one. Can we use Elasticsearch for doing text searching across all data files like Office documents in the data lake, or is it just used to aggregate events or reporting for Cabana? Okay, with Elasticsearch and how we index information in it as part of the data lake, because we can put information around the file counts, the number of rows, all of the file aliases, the business operational technical terms, we can do searches like this. We can go, show me where all of the customer data is, where we have an ID as a field, and it doesn't have PII. And what Elasticsearch can do can bring back all of the files, all the data file types that match that. And then you can drill into that and go, well, okay, if I can bring back all of the different file types, I should be able to do a second query and actually look at what real extended metadata is in there about the file types. And where we see people use that a lot is like in a subscription or a self-service model, everyone should be able to see the extended metadata, and they should be able to see what type of data is available within the organization. And then they should be able to go, well, okay, I can see who the data owner is, and I can see the security policy applied. So what I should be able to do using the API is the Elasticsearch API, and together with potentially some one or two other services with AWS, which I'd probably have to think about, you could send off a request to subscribe to a particular S3 location where the data that you want to query actually lives. So that's how we do that. If you're wanting to do text searches across all of the data files inside the data lake, that is a tricky one, because if you think of the data, like how I explained it earlier about that we're storing data in domains and then folders and then data partitions, we don't really have that wildcard search across the whole of the data set. So any last questions before we close for today? No? Well, thank you everyone again for taking the time today to hear about how we do the accelerated data lake. And thank you for all your questions. I really hope it's been valuable, and please reach out to me to ask any further questions if you have anything that you want to go deeper into. All right, have a great rest of the day. Bye-bye.